Hello, my name is Yu Tang Liu. I will present my work in 2022. This is an especially intense year for me. In the beginning of the year, I went to ICRA to present a work from my colleague, Nitin and Elia. Later this year, I went to IROS 2022 to present my own work, which I will introduce in a moment. Lastly, I received the first prize for my master thesis, which was co-supervised by Professor Elina Agari and Professor Amir Ahmed. My work focused on controlling the blimp autonomously with learning-based approach. The goal is to control the blimp to follow a sequence of waypoints. The reason we are doing this is because for an aerial odor capture system, a blimp has much higher endurance compared to any other aerial vehicles. However, blimp dynamics is highly nonlinear and suffers from large parameter uncertainty due to the fact that it is highly dependent on its environment. Reinforcement learning is a novel learning-based approach. The RL agent can increase control performance from the interaction data. Since it does not require any dynamic model, we can avoid time-consuming system identification. However, RL framework does not provide any control stability guarantees, which makes it dangerous and impractical to the real-world application. On the other hand, the conventional control approach can not only provide stability guarantees, but also attenuate noise and disturbance in an effective way. Yet without a well-parameterized dynamic model, it is usually difficult to apply such approach. To this end, we leverage a novel deep residual RL framework that leverage conventional control to provide stability and in the meanwhile improve overall performance by the RL agent. The residual RL framework mixes RL and conventional PID controller actuator command in different ways to preserve the PID stability properties. In general, the RL agent action can be seen as extra disturbance to PID controller. Hence, as long as PID controller can handle the total amount of disturbance, the control process will remain stable. Without PID controller, our agent can learn to achieve the task by unexpected behavior, that is flying backward as displayed in this clip. With the support from the PID controller, such behavior is prohibited, since the PID controller reduces the policy search space to those coherent to its own behavior. In addition, since PID controller can solve the problem from the start, the agent can efficiently explore a high reward region and greatly accelerate the training progress. As a result, we can see that the DR agent can successfully improve the PID control performance over time. With parallel training, the training can be finished within 2 days. So to bridge the sim-to-real gap, during training we randomize in the parameters, such as wind field, buoyancy, waypoint sequence. This way, we can successfully transfer the R agent to fly the real blimp. Here I would like to point out the most important missing pieces in current RL-based control, that is safety and sample efficiency. Although there are many good works in these two directions, their solutions are not always compatible. I would like to provide a novel perspective from multitask RL. Since we can formulate safety problem as a special task, we can actually tackle both problems at the same time. Multitask RL framework aims to design RL agent that is task agnostic. One important feature is that the agent should leverage the policies trained on the old tasks to accelerate the training of the policies in the new tasks. Therefore, it is possible to further increase the sample efficiency with this approach. More importantly, blimp control is not just about navigation tasks, but also include many other tasks such as hovering, taking off, landing, etc. Unfortunately, the multitask RL is currently a very underdeveloped field. Therefore, to understand the multitasking mechanism, we create new benchmark environment for training the multitasking agent. This environment can support more than 100,000 parallelization. Thank you for watching. We also openly provide the code in the link below. Check it out if you're interested.